So good afternoon everyone. I am Dr. Satyabrata, MDDM clinical pharmacologist, and today I am going to discuss on ANOVA, that is analysis of variance. So coming to introduction, what is ANOVA? ANOVA is a statistical method used to test difference between two or more means. And the name is appropriate because inferences about means are made by analyzing the variance. And Ronald Fisher introduced the term variance and proposed its formal analysis in 1920s. Then why ANOVA when independent t-test is there? Independent t-test only measures difference between two means, but ANOVA measures two or more means and also reduces the type 1 or alpha error. In the typical application of ANOVA, the null hypothesis is that all groups are simply random samples of the same population. For example, H0 is equal to M1 is equal to M2 is equal to Mi, where H0 is the null hypothesis, M is the mean of individual studies. Then coming to concept of factors and levels. ANOVA depends on factors and levels. Factors are the independent variables chosen by the researcher, and subjects depending on the factor are called levels. For example, experiment on effects of age and gender on reading speed in age group 8, 10, 12 years and gender male and female. Factors: age and gender. Levels: age has 3 and gender has 2. So between and within subject factors. Between group variance, within group variance, and between group variance, within group variance. So between group variance is large relative to the within group variance. So F statistics will be larger and more than critical value, therefore statistically significant. Conclusion: at least one of group means is significantly different from other group means. Within group variance is larger and the between group variance smaller, and so F will be smaller, reflecting the likelihood of no significant differences between these uh, three sample means. So you can go through the different books and articles to learn more about this image and picture and topic. Then coming to types of ANOVA: one-way ANOVA, two-way ANOVA, multifactorial ANOVA. It can be ANCOVA. So one-way ANOVA, most commonly used is one-way ANOVA. It determines means of more than equal to 3 independent groups, subject difference unrelated using one factor. Assumptions before doing ANOVA: populations should have the same variance, homogeneity of variance, populations are symmetrically distributed, and each value should be sampled independently from another value, that is, each subject should have only one value. Then step to compute ANOVA. So first of all, state a null and alternate hypothesis, that is H0 is equal to M1 is equal to M2 is equal to Mi. All samples have equal means. HA, that is alternate hypothesis, at least one of the sample has a different mean. So second step is state a error, that is 0.05, and calculate the third step is calculate the mean and variance of each groups in the study. Then fourth step is calculate the MSB, that is mean square between, and MSE, mean square error of the given data. Then MSC means mean of sample variance, that is based on the assumption of homogeneity of variance within each population. The MSE, that is mean square error, remains same for all group. MSB, that is mean square between, differs depending on the group mean and variance. Then step 5 is then compare the values of MSB and MSE, that is mean square between with mean square error. So if MSB is more than MSE, chances of null hypothesis to be rejected increases. That says there is a difference between the means in the sample. If MSP is equal to MSE nearly, then population means are equal and consistent with null hypothesis. Step 6, calculate the degree of freedom DF for MSB and MSE. For MSB, DF degree of freedom is equal to K minus 1. K is the total number of groups taken for study. For MSC, DF degree of freedom is equal to N minus K. N is total sample size and K is total number of groups taken for study. Then step 7 is compute the F ratio, that is MSB by MSE. This picture shows that small f is equal to sample means are very close, and typical f is equal to sample means about as far apart as you would expect if population means equal, and the color purple color rejection region upper tail only, and large f is equal to sample means far from equal. So this is the graph showing F statistics, density of F statistics under H0, null hypothesis. Then step 8 is calculate the p-value from the F distributor table. Then step 9 is then calculate the variance between and within the groups by sum of squares, SSQs and GM, grand mean calculation. Then step 10 is compute the variations of MSC and MSB by formulas. MSB is equal to SSQ, that is sum of squares condition, divided by DFN, degree of freedom n only into K minus 1, and MSE is equal to SSQ error divided by DFD into n minus K. Then step 11, put up the values in ANOVA table and compute analysis using SPSS software. So this is the formulas used in ANOVA. Mean is equal to x bar is equal to summation xi I is equal to 1 to n divided by n. Variance is equal to sigma square is equal to summation xi minus x bar square divided by n. So here sigma square is variance, xi is the value of the ith element, x bar is equal to the mean of x, n is equal to the number of elements. Then sum of squares formula is SS total is equal to SS factor plus SS error, and this is a complex thing. You can, and by comparing the sums of squares we can tell if the observed difference is due to a true difference or random chance. So SS total is total sum of squares of the experiment individuals minus grand mean. SS factor is sum of squares of the factor group mean minus grand mean. SS error is equal to sum of squares within the group individuals minus group mean. So you can go through different books and articles to learn more about this ANOVA and these formulas. Then computation in ANOVA table. So in the ANOVA table, one-way ANOVA table, an ANOVA table is often used to record the sums of squares and to organize the rest of the calculation. Format for the ANOVA table, source of variation, SS between samples SSB, within samples SSW, total SST is equal to SSB plus SSW, DF degree of freedom, between samples is for K minus 1, degree of freedom within samples is N minus K, degree of freedom total is N minus 1. So MS is between samples MSB SSB by K minus 1, within samples MSW is equal to SSW by N minus K, and F ratio is F is equal to MSB by MSW. So the sums of squares and degrees of freedom must check SS factor plus SS error is equal to SS total, or SSD plus SSW is equal to SST. DF factor plus DF error is equal to DF total, or DF between plus DF within is equal to DF total. So SSB here is sum of squares between the group, SSW is sum of squares within the group, SST sum of squares of total, K is equal to K is number of groups taken in study, N is total number of observation, MSB mean of squares between the groups, MSW mean of squares within the group, DF is degree of freedom. So this is a complex table, so you can go through different articles and books to learn more about this ANOVA. So coming to two-way ANOVA, factorial two or more way ANOVA, one dependent variable, that is interval or ratio with a normal distribution, two independent variables, nominal definite groups and independent of each other, three hypothesis tests, test effect of each independent variable controlling for the effects of the other independent variable. One is equal to H0 treatment type has no impact on outcome. Two, H0, the age group has no impact on outcome. 3. Test interaction effects for combinations of categories H0, treatment and age group interact in affecting outcome. So you can go through the book to learn about two-way ANOVA and also different articles and different authentic sites. You can go through about the two-way ANOVA also. Then two factors considered at one time. Factor 1, independent variable. For example, type of crop variety, always nominal or ordinal. It defines distinct groups. Factor 2, independent variable. For example, fertilizer, always nominal or ordinal. It defines distinct groups. Outcome dependent variable. For example, yield, always interval or ratio. Mean outcomes of the group defined by factor 1 and factor 2 are being compared. Then coming to factorial ANOVA as three questions and tests three null hypotheses. First is, does type of crop variety have any impact on the yield? Null. The groups defined by the type of crop variety will have the same mean yield. Second, does fertilizer have any impact on yield? Null. The groups defined by fertilizer will have the same mean yield. Third, do type of crop variety and fertilizer interact in influencing yield? Null. No combination of type of crop variety and fertilizer produces unusually high or unusually low mean yield. No mean yield. So factor ANOVA, three questions and tests three null hypotheses. So this is a very complex procedure. So two factor ANOVA, between treatments, within treatments, SS, DF, MX. You can go through this to know more about this. Go through the articles and books also. Then coming to post hoc testing. Post hoc testing is done to determine which mean or group of means is or are significantly different from each other. Only done when ANOVA yields a significant F value. The different tests are post hoc testing. The different tests are Skiff's test, Bonferroni test, Toki HST test. So to learn more about this, you can go through different books and articles, and you should know about the SPSS software and other software, also GraphPad Prism software, so that you can use this type of ANOVA in case of three different samples, and according to the data you have to choose the ANOVA, whether you can use one way, two way, or ANCOVA, etc., etc. So you should know about the SPSS, how to handle the SPSS software, and also how to handle the GraphPad Prism and other softwares if available, to analyze the ANOVA, to use the ANOVA, and and uh, and do a post hoc analysis after doing ANOVA if required. So this is a difficult topic, but you can know more about this on by learning a lots of books and lot on statistics, and also on different authentic sites also. So please completely watch the video so that you can learn uh, more more topics, uh, and also uh, you can learn more and more things from this channel. Please like and subscribe the channel and share the video so that lots of people will be able to know about these topics also. Um, so so that's all for today, and we will meet again on a different day. uh, Thank you very much for listening. Jai Jagannath.